The engineering design process, which we will discuss in this lesson, is different than the scientific method. Engineering is the application of mathematics and scientific principles to design and develop structures, machines, apparatus, tools, materials, components, and manufacturing processes. Engineering is very broad, but was originally broken down into only 4 main branches: chemical engineering, civil engineering, electrical engineering, and mechanical engineering. With the rapid advancement of technology during the 20th century, many more engineering branches were added. Some of these include aerospace engineering, manufacturing engineering, automotive engineering, nuclear engineering, biomedical engineering, and industrial engineering. Now let us look at what engineers do. Chemical engineers design and develop equipment and facilities to manufacture chemicals for food, fuel, drugs, and many other products. Producing drugs on a large scale, growing silicon crystals for devices used in electronic products, and the refining of oil are just some examples. Civil engineers design and manage construction of large projects. Examples include buildings, railways, bridges, roads, airports, and dams. Electrical engineers design electronic systems for computers, entertainment systems, mobile communication devices, instruments, and many other products or systems. Some of their work involves the design of circuits, the building of electronic system prototypes, and the planning of large electrical system installations. Mechanical engineers design aircraft, robots, assembly machinery, transportation systems, engines, compressors, and other machines used in development and manufacturing. Other engineering branches include automotive engineering, aerospace engineering, and industrial engineering. The study of the human body provides a link between medicine and engineering. Biomedical engineering involves efforts to sustain, repair, enhance, and even replace human body functions. The development of synthetic eyes, ears, and hands are 3 examples. There are some direct connections between art and engineering. Architecture, landscape design, and industrial design are just 3 examples. Business engineering is the development of processes related to the advancement of a business enterprise. These processes might be related to organizational structure, industrial engineering, management techniques, and information technology. The first step in the engineering design method is to define the problem. This is followed by extensive background research using both online and printed sources of information. The background research enables the engineer to specify the requirements needed to solve the problem. The next step is to study the problem further and develop a solution. This enables the engineer to design and develop a prototype or model of a new device to solve the problem. If the prototype does not meet the requirements or only solves part of the problem, the engineer makes design changes and builds a new prototype. Additional tests are performed, and the engineer makes modifications until the prototype fully meets the requirements and solves the problem. Finally, the engineer will communicate the results of the work with colleagues and management. A patent may even be applied for if the new prototype provides significant advancement over existing products or devices. Qualification testing is performed to verify the design and manufacturing process of new devices or products. These tests are also critical in determining if the device or system is ready for production. The engineer is often involved in transferring the device, product, or process to mass production. Mass production can be divided into two main categories. The first is called batch production. Batch production is used to process a product in groups or batches, where the products in the batch go through the whole production process together. These photos show examples of batch production. The second category of mass production is called continuous flow production. It is used when the product is built up through many individual steps. This method is the most efficient and effective because it uses automation. This video shows how automation is used in the continuous flow manufacturing of automobiles. Engineering is important because it drives technological innovation. Technological innovation has long been the key to the growth and prosperity of all nations. Engineering integrates scientific principles with research, providing systems and processes that create ways of acquiring new knowledge. The integration of science and engineering is critical to successful industrial innovation. This presentation was produced as a public service to help middle school and high school science teachers develop experiments and demonstrations that can be used in their classrooms. More science experiments and demonstrations are available on the Tops of Santa Clara Valley website, www.topsofscv.org. TOPS, Teaching Opportunities for Partners in Science, is a program aimed at stimulating greater interest in science by middle school students.